In this question, we want to find the equation of the perpendicular bisector of the straight line AB. So this is your straight line AB. A has coordinates -7 and 3, and B has coordinates +1 and -1. Now perpendicular means at 90 degrees to. So my perpendicular bisector will be at 90 degrees to the line AB. And to bisect means to cut in half. So the perpendicular line would be passing through the midpoint of AB. So first I'll find the gradient of the line AB, and then I'll get the gradient of a line that's perpendicular to AB. So first I'll write out the coordinates of A and B, and I'll label these coordinates x1 and y1, and I'll label these coordinates x2 and y2. And I'll call the gradient of the line AB m1. So m1 is equal to y2 take away y1 divided by x2 take away x1. So y2 is -1 and y1 is +3. So y2 take away y1 would be -1 take away +3. So I'll have -1 take away +3 divided by x2 is +1 and x1 is -7. So for x2 take away x1, I'll have +1 take away -7. So for the numerator, the sign in front of the two numbers are the same. So we'll add and keep that sign. So 1 + 3 is 4, and the answer will be -4. So I'll have -4 divided by, and for the denominator, we'll multiply these two negative signs and get a positive sign. So we'll have 1 + 7. So 1 + 7 would be 8. So we'll have -4 divided by 8. So that will be equal to -1/2. So now I'll call the gradient of the perpendicular bisector M2. So seeing that the perpendicular bisector is perpendicular to the line AB, if I want the gradient of a line that's perpendicular to AB, I'll just have to find the negative reciprocal of this number. So that will be the negative reciprocal of -1/2, which will simply mean inverting the number. So I'll have 2/1 and changing the sign. So therefore the negative will change to positive. So 2/1 is 2. So M2 is equal to +2. And this will be my gradient of the perpendicular bisector. Now, in order to find the equation of a line, we need two things: the gradient and any point the line passes through. So now that we have the gradient of the perpendicular bisector, we need a point that the perpendicular bisector is passing through. And we said at the beginning that the perpendicular bisector will pass through the midpoint of AB. So now I'll have to find the midpoint of AB. So to find the midpoint of AB, we simply add up the x components of the coordinates and divide it by 2. And we add up the y components of the coordinates and divide it by 2. So x2 is 1 and x1 is -7. So for x2 plus x1, I'll have 1 plus -7. And I'll divide that by 2. And y2 is -1 and y1 is 3. So for y2 plus y1, I'll have -1 plus 3. And I'll divide that by 2. So now we multiply these two signs, the plus and the negative, and we get a negative sign. So we get 1 take away 7. So I have 1 take away 7 divided by 2. And -1 plus 3 will give +2. So I'll have +2 divided by 2. 1 take away 7 is -6. So I have -6/2. And 2 divided by 2 is 1. -6 divided by 2 is -3. So -3, 1 will be the coordinates of the midpoint. So if I go on my Cartesian plane, here's -3 on the x-axis, and here's +1 on the y-axis. Therefore here would be my midpoint. So this is where the perpendicular line would pass through. So I just wrote out here the important things that we have found. The the midpoint of AB is negative 3, 1. The gradient of AB, which we call M1, is negative 1/2. And the gradient of the perpendicular bisector, which we call M2, is 2. So now to find the equation of the perpendicular bisector, we're going to use M2, which is 2, because this is the gradient of the perpendicular bisector. And we're going to use the midpoint, negative 3, 1, because this is the point that the perpendicular bisector passes through. So the equation of a straight line is y is equal to mx plus c. So where we have x, we'll put negative 3. And where we have y, we'll put 1. And of course, our gradient m would be 2. So for this y, we are putting 1. So I have 1 is equal to, and I have m times x. So m is 2 and x is negative 3. So that's 2 times negative 3. So m is 2 and x is negative 3 plus c. So I'll have 1 is equal to 2 times negative 3 is negative 6 plus c. Now I'll transfer this negative 6 across the equal sign, and the sign in front of it will change to positive. So I'll have 1 plus 6 is equal to c. So c is equal to 7. So now I can write for my equation of the perpendicular bisector, y is equal to m, and m is 2, x plus c, and c is positive 7. So this here would be the equation of the perpendicular bisector. So here we have the line of the perpendicular bisector, which has equation y is equal to 2x plus 7. You can see it passes through the midpoint, negative 3, 1, and it's at 90 degrees to the line AB.